Okay, before I do any algebra, I'm going to have to analyze four different regions here. Where will I possibly have an electric field of 0? Will there be any solutions over here? If I put a positive test charge anywhere over there, no, it's definitely going to go to the left. It'll repel from all three of them. Similarly, on the other side here, is there any solutions? No, it's if I put any positive test charges there, it's going to repel from all three of them. So there's not going to be any solutions on the left or the right of these three charges. It's going to be somewhere in the middle. Will it possibly be right in between two of them, like directly in the middle of two of them? And the answer is no, because let's say I'll number these charges off. So while the electric fields from 1 and 2 would cancel out in that situation, the electric field from 3 would end up pushing it to the left overall. So no, the answer will not be directly in between a pair of these. So therefore, I think it's going to have to be shaded a little bit. It's going to have to be shaded a little bit to the left here. Yeah, it's going to be slightly off from the middle, closer to the edge, so that, for example, in this case, charge 1 will push it to the right, whereas charges 2 and 3 will push it to the left. But charge 1 will be able to balance both of those other two charges because of the distance. It'll make up for it in the distance. So I think there may only be a brute force way to do this. Maybe not. There might be a way to use a lot of deep reasoning to get a shorter way, but I'm just going to brute force this. So I know the distances between consecutive charges is 1 unit. So what I'll do is I'll call the distance from charge 1 to my point, I'll call that x. So then the distance from my point P to charge 2 will be 1 minus x. And my distance from point P, I'm going to draw this. I'll use a different color. From point P all the way over to charge 3, that distance will be 2 units minus x. Okay, so those are my distances away from each charge. So in terms of setting up my equation, I'm going to need the electric field from charge 1, which pushes to the right. I need that to balance out the sum of the electric field from the other two, which are both pushing to the left. So that's the equation I'm going to solve. I'll replace them with the formula for electric field from a point charge. So K Q over x squared equals KQ over 1 minus x squared plus KQ over 2 minus x squared. So they all have the same charge of Q. The distances are different though, and that's why the denominators are all different there. All these K's and Q's will cancel, making this be 1 over x squared equals 1 over 1 minus x squared plus 1 over 2 minus x squared. So this becomes a math problem. Is this a quadratic? Is this... this may become a large polynomial, which I'm not going to deal with. I'm going to type it into Wolfram alpha. Okay, we have two real solutions and two complex solutions. So this is a degree 4 polynomial, actually, when you expand it all out. And there's only one solution that makes physical sense. I'm going to throw away the negative. It's giving me a negative solution. That's going to be inadmissible. The two complex solutions are not going to apply in the real world here. So the only solution that makes sense here is 0.48638 is what they are giving me. So, I mean, I suppose they do give me an exact form. You can click on something called exact forms, and I see a square root within a square root within a square root 6 times. So no, I'm not going to write out that exact form. This approximate form will be just fine. I mean, this is to 1 sig fig. If we do sig figs, I got to remember on the problem set to make sure we give more sig figs in the question. Okay, so P can be located there. Now by symmetry, there should be a mirror solution on the other side. Should be a mirror point right over here. I'll call that Q. Q, which is the same units away, but I'll say left of charge 3. All right, so yeah, I did the math to get the P, but yeah, by a symmetry argument, you should have an identical solution on the other side.